Hi everybody, Omar from Weavechain here, and I'm thrilled to present our work with Rootstock to establish verifiably licensed data and training for AI and more. We are seeing the Napster situation from 25 years ago happen all over again, with AI trainers abusing the copyrights of publishers at scale with their new services. It's disenfranchisement at scale, and it's not just limited to training models. Now AI services are providing smart summaries of news sources and stealing the page views of content providers because nobody clicks the source link. Our solution helps content providers protect their data advantage by making it easy for them to charge for the right to access their data, providing them with licensing mechanisms to quickly identify illegal data, and helping them to secure their advantage with cryptography. This is what Weavechain does. We help you treat data like a first-class citizen. All the data flows involving Weavechain are provable with immutability guarantees for each step in your data lineage. And blockchains allow us to make data flows truly exchangeable with the ability to monetize both data transfers and API calls. And of course, all of this is anchored to Rootstock, the most secure blockchain powered with the security of Bitcoin. Today, we're going to demonstrate two key features of this framework. First, we need to be able to identify illegally sourced information. And so we'll show a distributor portal designed to receive articles from creators, where we then use content credentials to create a signed manifest as a license, anchored to Rootstock to create immutability guarantees. The content credential standard was pioneered by Adobe, and just this year was adopted by Meta, Google, and myriad other players. Next, we want to showcase how we can establish verifiable computation for use with AI. Today's AI are black boxes, where you don't know how they trained it, and you don't know how the API is returning your summary. Weavechain changes that, letting you both prove that this is the model that this model was trained on this licensed data, and that a specific inference was rooted in that precise licensed model. This will be critically important as legislation like the US AI Act comes into effect, requiring licensing of audits and audits of all training data. Now let's see this in action. I want to preface by saying that we're walking through a UI flow that was mostly built for demonstration purposes. Most of this cryptography will be completely transparent to end users and monitored automatically. Great. So in our scenario, I, as Weavechain, own the copyright to my article on an intro to Web3. So I'm going to come over to our portal for licensing content to different publishers. And I'm going to drop the content of my article right in over here. And I'll click Submit. Now, right at this moment in time, we actually anchored a license for this content to Rootstock. But I want to show you first the license itself in consumer-friendly terms. So inside this article that was posted on the publisher's website, we have this little CR logo. And this is the content credential, which is really just a JSON manifest that highlights, who the copyright holder of the data is, Weavechain in this case, which publishers have rights to go and redistribute the data, so Yahoo here, as well as a variety of hashes and signatures that can be used to identify and verify the legal chain of custody for this file. Now, this is the standard that is being designed as seamless and unobtrusive. And, the idea behind these certificates is that they're the same thing as what your browser is using to actually show that this is a secure website, right? Very few people are actually looking at these hashes and validating if they're okay, but your browser does it for you automatically. And if you're ever on a website that is not secure, you get a very noisy message, sort of scaring you away. Now, what's really extra special about Rootstock in this situation are the immutability guarantees that they're providing to this license or manifest file. This unparalleled smart contract blockchain security is backed with the security of Bitcoin. And we can come over to our testnet Explorer, do a quick refresh, and look at the most recent transaction over here, and see inside the transaction, let's see, details, this input, we can copy and paste into a hex decoder to see that what we are actually putting into Rootstock are those signature fields, right? These are the signed keys, just like these certificates on the website, And now by immortalizing them in Rootstock, we can always go back and say that, yes, we did have a valid license at this point in time ready for use. So we just looked at our solution for licensing the data. And now let's see how we can extend that pattern to have verifiable training for AI. So over here in my Jupyter notebook, Weavechain nodes allow us to sort of run computation directly through them. A full compute job of this Docker image over here, for example. And in this case, that image is going to train a large language model on the article that we just submitted. Now, what's special is that we actually apply our hashing methodologies to computation as well as data. So we take a hash of the actual code being run, that Docker image itself that I showed you up here. Then we go and take a hash of the input data being used, right? So the article that I showed earlier, where we have that nice content credential showing that I have a license to the data. And then we go and take a hash of the output of this calculation. So in this case, this would be the trained large language model that used this data. And same thing as before. We're going to take each one of those hashes and put them into a smart contract on Rootstock so that we have a sort of verifiable lineage of the data. And at its simplest, this lets us prove that a specific model was trained on a specific data set that we had licenses for. You don't need to know the secret formula for what makes GPT-9, right? You just need to have a Merkle root of this input data set that's publicly available, and the ability to compute the hash for your data. And this is really where things like Merkle trees become really handy over here. In this case, I can go and show that if we put my sample article data in over here, then we can check its presence in the Merkle tree. And of course, we don't want our users to actually be doing this in code. So back on the Verifiable website, I can come in and paste the content of my article one more time. And then see a nice, happy check mark over here saying that that content is included. And, this isn't movie magic. If I go and delete a big chunk of it and run my call, it'll show that this does not exist in the tree. We think it's time to stop treating your data like a public good and time to start protecting your assets. Please reach out or schedule time to learn more about the future of your data.